may want to get out those flashcards that you've already been making about perpendicular bisectors and angle bisectors, because we're going to be adding to them today. First thing we're going to do is we're going to look at perpendicular bisectors. The blue segments in the picture you see here in front of you indicate the perpendicular bisectors of each segment. In other words, D, E, and F are the midpoints of the sides, and they're perpendicular to the sides. So those are perpendicular bisectors. In any triangle, all three perpendicular bisectors intersect at a common point. That's actually kind of cool that they do. That point has a special name, and if you haven't figured out what that special name is yet, it's called the circumcenter. Now you're saying, why the circumcenter? What does that mean, circumcenter? Well, let me just show you a little something. I'm going to draw a circle here. And I'm going to center that circle at P. And if this is drawn accurately, and it's pretty close, what do you notice about that circle? That all 3 points of that triangle are right on the circle. B is a little off because my center was a teeny bit off when I first drew it. But I can fix that. Oops, come here. Here we go, come here. Here we go. Here we go. So the center of that circle, I'll do it in red because it makes sense, is right there. Why does that work? Well, what did we know about any point on the perpendicular bisector? Every point on the perpendicular bisector was equidistant from the endpoints of the segment being bisected. So if I look only at, say, segment BC, so for a segment, let's just isolate our focus on segment BC. And I know that PE here is the perpendicular bisector. Then I know that these two segments, PB and PA, have to be congruent. That's what we learned. They're like radii of a circle. They're congruent. It's the circumcenter. And you could repeat that for any 3 sides. So all 3 of them wind up being the same distance from the vertex. That point is the circumcenter. Circum meaning draw around. Circum around. To circumnavigate the globe means to go around the globe. So this circle is the circumcenter of the triangle. That's an important point. So take that perpendicular bisector flashcard you have, and maybe write on the back of it the point of concurrency that's what we call this. It's where all 3 come together, all 3 perpendicular bisectors come together, is called the circumcenter. You're going to need to know that. That should be on your flashcard. All right, that's great. All 3 of those segments are congruent. That can be really useful for us. It says 3 snack carts sell frozen yogurt from points A, B, and C outside a city. Each of the 3 carts is the same distance from the frozen yogurt distributor. Find the location of the distributor. Well, if all 3 vertices are equidistant from the same point, what do we have to do? We have to find the perpendicular bisector of each side. And of course, obviously here, this is a random guess, but the perpendicular bisector here, here, and maybe here, aha. Those are the perpendicular bisectors. And I'm guessing, obviously, right here. I'm not constructing. So that'll be equidistant to all 3 vertices. Obviously, I didn't do a great job guessing, but you get the idea. Next one is the incenter. So get out that flashcard that deals with the angle bisectors, because guess what? Angle bisectors work a little differently. Here the red segments are my angle bisectors. And what do we know? The angle bisectors are equidistant from the sides of the angle, so the congruent segments here are the blue ones. Those are all congruent. I've got 3 congruent segments coming out from a point that's like spokes in a wheel, which makes me think circle. So I'm going to center my circle there. Again, I'm a little bit low and off, but you're going to get the idea pretty quickly. I can fix that. Wait, I can fix that. There we go. And what kind of circle do we have here? We have an inscribed circle. It is inside the triangle. Hence the name where the 3 angle bisectors intersect. And by the way, isn't it interesting that all 3 perpendicular bisectors intersected at a point of concurrency, at a common point? That was cool. Not only that, though, all 3 angle bisectors of a triangle will intersect at a common point. That's amazing. Math is orderly. I like that about math. Things worked well together. This point of concurrency is called the incenter. So add to our flashcard for angle bisectors, point of concurrency is the incenter. It is equidistant from the sides of the triangle versus a circumcenter, which is equidistant from the vertices of the triangle. Here it is clearly not equidistant from the vertices. Okay, AP, BP, and CP are clearly not all the same. BP and CP might be kind of close. AP is way longer. So it's clearly not equidistant from the vertices. This is equidistant from the sides. Again, how do we use this stuff? Well, we use it to set up and solve equations. It's really, do you recognize the relationship and can you use it to help them set up and solve an equation? What parts have to be congruent? And we can use a little bit of common sense here. If I'm not sure if the segments from the point of intersection to the vertices are congruent or from the point of intersection to the sides are congruent, a lot of times I can just look and say, well, my red segments clearly here are not all the same length, but it appears that my blue segments approximately are, not counting NG, which really shouldn't be there. Okay, but NF, NE, and ND all do look the same. Aha. Equidistant from the sides, that's an incenter. Very quickly then I can set up, if ND is 5x minus 1, and NE is 2x plus 11, it says find NF, which has to be the same as ND and NE. So I'm going to have to solve for x. So 5x minus 1 equals 2x plus 11 minus 2x plus 1. I get 3x equals 12. So x is 4. So now NE is 2 times 4 plus 11, or 8 plus 11, or 19, and NF must be the same. Next question says, can NG be equal to 18? That's why NG is drawn in there. NF is 19. That's an established fact now. Can NG be 18? The answer is no. Of course it can't be. NF is the distance from N to the line AC. That's what NF is. It's the distance from the point N to the line AC. By definition, the distance is the shortest distance. So any other point that I pick, like G, right here, on line AC, has to be farther away than 19. 19 is the minimum distance. It is impossible for it to be less than 19 in this picture. All right. So it's the circumcenter and the incenter. We're going to keep looking at these two a little bit tomorrow. But make sure you get those on your flashcards. Make sure you understand the difference. We're going to spend time working on it in class, looking at problems with it, and hopefully nail down these differences. Usually you can tell by common sense and by looking and analyzing the picture.